This video is going to show you how you can actually calculate the return and standard deviation on Excel. You can also follow the formula and then doing it on your calculator. So the problem is actually, so the first problem we're going to use is actually from chapter 10, and it's problem 2 at the end of the chapter. So if you want to find the problem, the original problem, you can go back to the end of chapter 10. So you're provided with the probability and the corresponding return. This is what we call a probability distribution, or we can also call it a return distribution. So what it provides you is the actual return you're going to receive with how likely you're going to receive that. Okay, for instance, this over here, it means you're going to receive negative 100% return with 40% likelihood. And you're going to receive negative 75% return with 20% likelihood, and so on and so forth. Okay, so the sum of your probability should equals to 100. Okay, so in this case you have 40% plus 20% plus 20% plus 10% plus 10%, which exactly equals to 100%. You can check it out. So sum of your probability. The reason your sum of the probability has to equal to 100% is because one of these scenarios has to happen. Okay, so if your probability doesn't sum up to 100%, then you don't have a complete return distribution. Something is missing. Okay, and then you have to figure out what's missing. All right, so the first thing you're going to do is you need to calculate the expected return, which is essentially is like a weighted average calculation. Okay. The only thing is over here, the weight is actually your probability. So what you're going to do is you're going to start with the probability times my return plus probability times my return plus probability, again, times the return, and plus my probability times the return plus the last one. So what this really means is, on average, you're going to receive 32.5%. Okay, you may wonder, did I really get this percentage in return? The answer is no. In reality, you're going to get one of these returns that's presented over here. Okay, but this is your expected return, which is the average return. Okay, it doesn't have to be the same as your real return. Okay, all right, so to calculate standard deviation, you actually there were two ways you can actually do, if it's equally likely, if you have the same probability, you can basically use the Excel function. Okay, they do have the standard deviation function in Excel, but you want to make sure to use the standard deviation for sample, not for population. However, in this case, you cannot use the Excel building function. Why? Because the probability is different. Okay, which unfortunately the building function doesn't really take care of this scenario. So what we're going to do is we're going to identify the differences. So we're going to figure out how far away my return is from my expected return. Okay, so my X bar here is essentially the expected return. So this row over here is capturing the difference. So my return is negative 100%. My expected return is 32%. I'm going to just anchor this number. The reason I anchor it, so I can actually just scroll it to the right. Okay, all right, let me just convert it to percentage. Okay, so it's a bit easier, so you can actually see. All right, so now I'm getting, basically the differences between what I'm gonna receive in reality versus what I expect to receive. So this is basically the gap I'm talking, And then because standard deviation, you have to go through the variance route, and variance is actually a square term. So you have to make sure to square every differences. Okay, so what I'm gonna do is I'm just gonna square this term. Okay, and then again, let's go across. Okay. One thing you notice is after you square it, it becomes all positive. Okay, so that's something that's really important. Keep in mind your standard deviation and your variance should always be positive. Okay, you should never get a negative standard deviation. Okay, if you ever receive a negative standard deviation, something is wrong. Double check your calculation. All right, so next thing is I'm gonna multiply the probability to my squared differences. Okay, why do I multiply that? Because what I know is these differences only occur when I receive this particular return. And this return only occur with 40% likelihood. Okay, so that means my differences for this case only occur 40% likelihood. So I'm gonna multiply that. Okay, all right, so now I have all the information I need to calculate my standard deviation. So my standard deviation is the square root, so square root of my variance. And my variance is basically the sum of all these numbers. Okay, so you probably have seen this formula actually in your textbook. So the sum of the probability times the standard deviation, the sum of the probability times the differences square is essentially your variance, and the square root of your variance is going to be your standard deviation. Okay, all right, so now let's take a look at a different question. Okay, it's question 27, again from chapter 10. So this problem says, suppose the risk-free interest rate is 5%, blah, blah, blah. So they provided with different kind of scenarios. So you have the stock market, which has the likelihood of getting either 40% or getting a negative 20% each year, with each outcome is going to be exactly the same. And then you're going to compare the following two investment strategy. So we're going to take a quick look at what exactly is going on here. So first, you're going to invest for 1 year in the risk-free investment, and then 1 year in the market. Okay, all right, so the return for that is going to be, so return in high state, right? So that basically tells you, okay. So for return in high state, what is a high state? High state means you're getting actually good returns, from the stock market. So what we're gonna do is we're gonna have, so for the first year, because it's a risk-free, so you're gonna receive the 5% regardless, okay? And then multiply by the second year. So for second year, when it's a high state, you're gonna actually receive 40%, okay? Wait, oh, sorry, never mind. Okay, something went wrong here. Okay, so you're gonna do plus 40%, and then you're gonna subtract 1. Okay. So what this number really means is, because the first year you invest in the risk-free asset, so you're receiving 5% return, and then you compound it for the second year, you invest in the stock market, and then when it's a high stake, you're getting 40% return, so you multiply 1 plus 40%, it's like compounding, right? And then you're subtracting 1 because 1 is the base, that's your principal, so you're going to subtract it to get the percentage return. All right, so for the return in low state, again, very similar. The first year, your answer is still the same because it's a risk-free asset, so it doesn't really matter. For your second year, in this case, you're going to use the negative 20% instead of the 40% because the return is actually worse. So you're going to get negative 16%. So your expected return is going to be, because it's going to be 50%, 50-50 likelihood. So all you're going to do is you're going to do an, like average between the two, right? Average of the two. Okay, And your standard deviation, because it's 50-50, equally likely, like I said, you can basically use a standard deviation function if you want. So let's try. So we will do STDEV dot, let's try 2 number. Okay, then I can see like how different it is. Okay, so this is the first number. Okay, notice here this is a standard deviation dot p. Okay, what this means is you're going to assume this is a population. Okay, now let's see how your number is going to be different if you use a different built-in function. STDEV dot s. Okay, still selecting the same number. Notice here it's different, right? It's actually higher if you treat it as a sample. Okay, so the question is this a population or is this a sample? Okay, an easy way to to determine is actually by asking yourself, is your return distribution kind of complete? Okay, in this case it is, because you have 50-50 combines 100%, so it is a complete return distribution, so it is a population, it is not a sample. So you're going to use the STDEV.P instead of the STDEV.S. Okay, when the case give you only partial information, let's say if you're provided with monthly data for the last 5 years, but you're only trying to figure out the standard deviation for the last 3 years, then you don't really have a complete return distribution. Okay, in that case, you're going to use the sample standard deviation. Okay, all right, so let's take a look at strategy 2. So for strategy 2, you're going to invest for both year in the market. Okay, all right, so return if market is up for both year. So when you actually invest in the market for both year, then what we're gonna have is when it's up, then you're gonna have 1 plus, okay, 40% square, right? Because it's for 2 years, okay, and minus 1, so you're gonna have 0.96, and return if market is up for 1 year. Okay, so let's suppose the first year is up, so you have 40%. And the second year is down, so you have a negative 20%, and then you minus 1. Okay, and you may also have, both year being in the down market, so you're gonna have 1 plus the negative 20% square minus 1. Okay, so notice here your return actually you have 3 different returns now because you have 3 different scenarios. In strategy 1, you only have 2 scenarios because you only need to consider the high state and low state in the second year. But now you actually have 2 years both in the market, so you can have 3 different combinations, right? Both good, both bad, or 1 good, 1 bad. It's actually a little bit tricky. So you're going to consider the probability of these scenarios going to happen. It's not equally likely though, because if you want both here to be up, that means you have 50% likelihood for the first year to be in the high state, and then you have another 50% likelihood for the second year to be in the high state. So if you want this scenario to happen, you actually have 25% likelihood. If you want 1 year to be up, 1 year to be down, then you just have 50% likelihood. And then if you want both year to be down, you have again 50% in the up state, in the down state, and then 50% in the down state, so it's 0.25. So your expected return is actually going to be probability times the corresponding return plus probability times the corresponding return plus probability times the corresponding return. Alright, so when you're calculating standard deviation, again, what you're going to do is now, because it's not the same likelihood, so you can't really use a built-in function, so we're going to make it a bit, we're going to try to figure out what is the, let's call this differences, right? So we can just say the differences. So it's going to be the actual return minus the expected return. Okay, because actual minus expected minus equals actual minus expected, and then you're going to square the differences. Okay, and then for the standard deviation over here, it's going to equals to the square root of some actually we can just say square root of the probability times the differences square plus probability times the differences square plus the probability times the differences square. Okay, all right, so that is going to be the answer, right? So now let's go back to see so which strategy has expected payoff highest. So the first one you have 15.5%, the second one you have 21%. So strategy 2 you have a higher expected return, right? And you also have a higher expected standard deviation, higher standard deviation for strategy 2. So now when you compare strategy 1 and strategy 2, you can clearly see the relationship between risk and return. Okay, when you want to get a higher return, you need to take on a higher risk, okay, which is indicated by the standard deviation. Okay, all right, and then this holding period for decrease your risk. Theoretically, if you hold it longer, it's not going to be decreasing your risk. It's really just about like the states, what's the probability of different states going to happen and what kind of returns you expect to receive. Okay, all right, now let's take a look at a question from chapter 11. It's from question 7. So you want to look, figure out portfolio standard deviation, portfolio expected return. So far we only talk about single asset. We didn't really talk about portfolio. So we're going to take a look at how return and standard deviation calculation different from portfolio. So in this case, you have stock A and B. It's a 2-asset portfolio. You're going to invest 70% in A, which means 30% in B, because combined, it's going to be 100%. Okay, you want to be fully invested essentially. So you're provided with the return information for both stock. One thing you can definitely do is you can figure out the average, right? It's easy. So the average of that is going to be average. And then we can also, hold on. We can also do standard deviation, right? STDEV dot P, again, because this is for the entire population. Okay, so I just go down. All right, so that tells me the average return standard deviation for my individual stock. Again, I can clearly see when I expect to have a higher return, I need to take on a higher risk. Okay, risk and return. So if you wanted to do the portfolio, there are 2 ways you can do. You can either try to figure out the portfolio return individually by year and then try to figure out the expected return at the end. Okay, let's try this, the first step. So I want to do the average, not the average, sorry. So it's going to be 70% of my A, it's a weighted average, plus 30% of my B. Right, so expected return of the portfolio is going to be a weighted average of the individual stock return. And then my expected return for the portfolio is going to be the average of all these numbers. I think I might have average. Okay. Yeah. Okay. And then my standard deviation is going to be STDV.P. Again, all the numbers over here. So this is one way, okay? So when you combine the two, you get a portfolio, and the expected return of the portfolio is going to be 6.05%. The standard deviation of the portfolio is going to be 8.24%. Another way you can find out is you can find out using the correlation coefficient and then follow the formula of a two-asset portfolio variance, okay? All right, so to figure out the correlation coefficient, it's actually pretty easy to do on Excel. So you can just use correlation. So they're asking for two array. So the first return is going to be the stock A return. The second return is going to be, hold on, I'm not really selecting everything. So I want to make sure to select everything. So I want everything in my A. Okay, and then I want everything in my B. So this is going to tell me the relationship between A and B. Okay, in this case, I'm getting a correlation coefficient between the two of 0.06. It tells me two things. One, it tells me the direction of the relationship. Two, it tells me the strength of the relationship. So for a positive number, it means they're positively correlated. So when A goes up, B also goes up. For a number that's small, because it's really close to 0, that means the relationship between the two assets is actually pretty small. Okay, pretty weak, I should say. All right, so the standard deviation of the portfolio using equation is going to be what? Is going to be my weight in A, which is 70%. I'm doing 70% square times my standard deviation of A square plus my weight of B. My weight of B is going to be 30% square times my standard deviation of B square. Okay, and then I also have the 2 times standard deviation of A times standard deviation of B, and then times my correlation coefficient. Okay, notice here, this is going to be the variance, and then to get the standard deviation, I would just say square root of that is going to be my standard deviation. Okay, so again, so the number is going to be pretty close. We'll have okay, so now you look at the number, you'll be like, oh, this is the standard deviation I obtained using the formula, right? That's a two-asset portfolio variance formula, and then from there I get the standard deviation of the two-asset portfolio. But then you notice the number here is slightly different from the number over here. The question is why? Okay. The reason the number is slightly different because this formula usually assumes you are calculating a sample standard deviation, not the population standard deviation. Remember when we do the calculation over here, we actually use the population standard deviation. Now let's see how our number is going to be different if we instead using a population standard deviation, using a sample standard deviation. So I'm still doing the same thing. Okay, again, as you can see, the two numbers are identical now. Okay, so keep one thing in mind. If you're trying to use the formula from the textbook to calculate your standard deviation by using the variance, the number you are getting is going to be the sample standard deviation, not the population standard deviation. Okay, in other words, when you do the portfolio standard deviation and then you wanted to use a building function in Excel, also make sure to be consistent using the sample standard deviation building function, not the population standard deviation building function. So